Hey class, this is Station 5, Magnet Motion and Repulsion Race. This is pretty cool. The goal is to explore how magnets can move objects without touching them and investigate attraction versus repulsion, okay? So attraction is together, repulsion is away from each other, okay? So the task is we're going to place two bar magnets on the surface. We're going to turn the magnets so opposite poles face each other, observe the attraction. Turn magnets on so the same poles face, observe the repulsion, try to race one of the cars, okay? Thinking props. What happens when the like poles face each other? Make sure you answer these. What happens? Can you make an object move without touching it? Is it possible, okay? So what you're going to do is you're going to take some cars. Now, if you notice these cars, they have a north and a south pole, okay? You ever hear that expression, opposites attract, okay? So there's a north and a south pole, okay? And what you're going to do is you're going to start out with the two norths. See if the two norths face each other, right? What happens? Watch this. See that? Isn't that pretty neat? They're doing something. There's a word that we're studying at the top that happens right there. And then if we flip it, right, the north and the south, put them together, what happens? Let's watch that again. What happens? That's pretty cool. You guys are going to have a better table than this. This is actually material on top. But you're going to have a better table for this, okay? So what type of force, push or pull, did you observe? We're going to collect some data. Data table showing distance moved, attraction versus repulsion, okay? All right. So what you need to do is for this, okay, you're just going to draw a little graph right here. And at the bottom, you're just going to put the north and south, okay? So about how far apart does that happen, okay? You're going to have a ruler right there to measure it, okay? So, and then measure how far apart will they actually stick together, okay? And then try the other side, the repulsion, okay? The repulsion of it, okay? So the repulsion. See how far it is, okay? So see if you can do it from 2 centimeters, 4 centimeters, 8 centimeters. See if it works. So all you're going to do is a nice little chart, 2, 4, 6 centimeters, right? And see if it does work at that distance or it does not work at that distance, okay? Okay. How do you know a force is acting even though the magnets don't touch, okay? How do you know a force is acting even though the magnets are not touching? Is it possible? Do they have to be right next to each other in order for it to happen? Or can they have some distance to it? That's what we're going to answer in that question, okay? And then the extend, what could this tell us about the space around the magnet, okay? The space around the magnet in all directions, okay? What does it tell us about that space, okay? Is anything happening there? What do you think's happening there, okay? Different things like that, okay? All right, so once again, I'm going to go over that chart real quick that you have to do. So you're just going to draw a real quick little bar chart. You're going to put 2 centimeters, 4 centimeters, 6 centimeters, 8 centimeters. See how far apart it takes, okay? See how far apart it takes. Now, we have different size magnets. Like these are different sizes here, okay? These are smaller ones. They're pretty powerful, but they're smaller ones. You guys can trade in your group, okay? Notice the colors, right? They're together, right? See that? That's kind of neat, okay? But watch this. When I flip it over, what happens? See that? Isn't that kind of cool? Okay, so that's what we're going to do. Okay, make sure you draw that chart. Make sure you, if you have any questions, raise your hand. I'll be around to help you guys.